section 11, 6, and 8 deals more with the same idea of 4 and 5 where we're still talking about zeros, but this time we're going to go into a little bit more of the complicated situations. Yesterday we dealt with polynomials that factored nice and we could find the zeros. Okay. Today we're going to look at situations where it doesn't work out as nice. So we have to use different methods, okay? So sometimes we may actually have to use the quadratic formula to solve, and that is when you start looking at something and you cannot factor it. So if we started to look at this first equation, 5x squared minus 6x plus 11, and we try and factor it, we're not going to get anywhere, okay? It's not going to work and you're going to get frustrated and you're going to go, oh, it's prime, okay? Well, it may be prime to be factored, but that doesn't mean that there aren't any x-intercepts, okay? So we're going to use the quadratic formula, and if you forgot it, okay, it's right here. Remember that your a is your coefficient on the x squared, the b, and then the c. So if we use our formula, we're going to have x equals the opposite of b, which will be 6, plus or minus square root of b squared, so negative 6 squared, minus 4 times a, which is 5, times c, which is 11, all over 2 times a, which is 2 times 5. Then if you remember from here, you were to figure out what was underneath the square root next, okay? So in your calculator, you're going to type in just how it's written, parentheses, negative 6, parentheses squared, minus 4 times 5 times 11, and you're going to get the square root of negative 184. Now, are there any positive reals that come out of the square root of a negative? No. Okay, so this negative is a problem. And if you remember, if you square root a negative, you have imaginary answers. So in this equation, we have imaginary zeros. Okay, so that's why we couldn't factor it. That's why it's primes, because they're imaginary. Okay, and that is always going to happen, okay, when this discriminant is less than 0. And remember, the discriminant is this b squared minus 4ac part. So if it's ever less than 0, you're going to say imaginary zeros. Okay, so if we look at example B here, 169x squared, da 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 da. Again, if you try and factor that, it's not going to get you anywhere. Okay, so let's go ahead and use the quadratic formula again. So we'll have x equals the opposite of b, so 442 plus or minus the square root of b squared, negative 442 squared, minus 4 times 169 times 289, all over 2 times 169. Okay, so again, you're going to type in everything that's underneath that square root here. So when you do that, you're going to get 0. Okay, so now the question is, when I plus or minus 0, I still get 0. So this kind of doesn't matter. All we're going to get is 442 divided by 338, which is approximately 1.31. Okay, so here I'm supposed to have 2 zeros and I only have 1. So what this is called is multiplicity. So we're going to say 1.31 has a multiplicity, okay, of 2. Okay, so what that means is it just crosses at that same place twice. So anytime you've ever had to factor, so something where this might look familiar is if you had like an x minus 5 and an x minus 5. So that means you have the same factor twice, which only technically counts as 5 as 1 0, but you see it twice, so it's called a multiplicity, okay? So you just see it twice. This is always going to happen when your discriminant is exactly 0, because when you plus or minus something, you just get 0 and it doesn't change anything. So these are some of your special cases. There are more special cases when you have something like these two equations, okay? You can't factor it because they're just ugly. Like, you don't know how to factor anything like D, okay, you could factor it, like split it down the middle, but it's not going to work out. If you try C, you have an x to the 5th, but this one doesn't have, the 2 doesn't have an x, you can't pull that out. Okay, so you're going to use the graphing on your calculator to find these zeros when the equation cannot be factored and is not quadratic. Okay, so the first case that we looked at today, okay, these couldn't be factored, but they're both quadratic, okay? These can't be factored, and they're not quadratic, so we can't use the quadratic formula. Okay, basically what it's going to look like is a high-powered, okay, high-degree polynomials that are really long, okay, so that you can't factor them. It's hard for me to show you this, okay, so tomorrow we're going to show you how to do it on the calculator, so you must bring your graphing calculator, okay, and I'll show you how to do that tomorrow. So for now, let's go ahead and look at example F, okay, and look at this type of problem. So this type of problem says, what are the total number of zeros? Okay, so this time, instead of giving us the polynomial written in standard form, which is what we were just looking at, now we're looking at it in factored form. Okay, so this looks like factors. So I want to know how many zeros there are, which ones are real, which ones have multiplicities, and which ones have imaginary zeros. Okay, so what I think is helpful first is for you just to take a look and solve each one. Well, each factor, okay, we set equal to 0 to find the zeros, correct? Okay, so let's say x squared minus 9 equals 0. That means x squared is going to equal 9. That means x is going to equal, and here's the part you're going to forget, plus or minus 3. Okay, because when you square root something, you get two answers. Okay, so far I've got that. Now if I look at my next factor, now I've got x plus 4 equals 0, so x equals negative 4. Now what's tricky here is this little 2 standing out here on the outside. An outside exponent means that this is going to have multiplicities, okay, because that really means there's an x plus 4 and there's an x plus 4. So this negative 4 has a multiplicity of 2. Okay, so the exponent on the outside means a multiplicity. All right, now let's look at our third factor. So now we've got x squared plus 100 equals 0. So if we go to solve that, I'm going to subtract 100. But now I'm square rooting a negative 100. Again, anytime I square root, I get a plus or minus, so no big deal there. But remember, when you square root a negative, you need an I. So this one becomes plus or minus the square root of, plus or minus 10I. Okay, so please look at these three, okay? They are very similar looking if you look too fast, but as you look closer, you're gonna realize that they are different, okay? So the total number of zeros I have, okay, so on my first factor, I have a plus or minus 3, so that's 1, 2. Negative 4 is a multiplicity of 2, so there's 3, 4. And then over here, I have a plus or minus 10i, so there's 2 more. So I have a total of 6 zeros here. Okay, the real roots are the normal numbers. So that means I have 3 and I have negative 3. Okay, negative 4 is a real number, but it has multiplicity. So that's going to go under part C. So negative 4, which has a multiplicity of 2. And then the imaginary roots are the 10i and the negative 10i. Okay, so again, if you depending on what you feel more comfortable with, if you label them first and you kind of write them out like we did here, then you'll see that we have 6, so you can work yourself backwards if you prefer that. Okay, so let's try another one. So G is the same idea. It's in factored form, so I'm going to find, name, and classify the roots. Okay, so again, you take each factor and you set equal to 0. Okay, so this one, if I would add 5, okay, I would square root it. And when I square root it, I get plus or minus the square root of 5. Okay, but don't forget this little 2 out here means that this has a multiplicity. Okay, so that means the square root of 5 has a multiplicity of 2, and negative the square root of 5 has a multiplicity of 2. Okay, so when you have a multiplicity and you have two answers, the multiplicity goes on both. So this one actually counts for 2 here and 2 here. So far my tally's at 4 zeros here. Okay, the next piece is the 3x plus 4 equals 0. So I would subtract my 4 and then divide by 3. So I get negative 4/3. Again, this outside exponent means a multiplicity. So negative 4/3 has a multiplicity of 3 this time. So if I'm tallying, I've got 3 more here. Okay, now my last one, I've got 9. That's not very good. I'll do it in this color. 9x squared plus 25 to equal 0. So I will subtract my 25. Then I will divide by my 9. And then I'll square root it. Okay, so when I square root this, I always get a plus or minus. The square root of 25 is 5. The square root of 9 is 3. There was a negative here, however, which means this is going to be I. Okay, so plus or minus 5/3 I. The positive one is the negative is 1, so now I've got 2 more. So I've got a total of 4, 5, 6, 7, 8, 9 total zeros. Okay? All right, so that is that. Hopefully I can maybe clarify a few things and then show you the calculator portion tomorrow. Okay, so write down what you still do have questions about this and bring those to class tomorrow.